Hello everyone. In this video, we'll be solving problem 70, climbing stairs. The problem statement is you're climbing a stairs and it takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb the top? Let's look at example number 1. When there are total number of 2 steps, there are 2 possible ways we can get to the top. One is to take 1 step twice or taking 2 steps once. Let's look at example number 2 where total number of steps is 3. To get to the third position, one option is to take all single steps. One is to take the first as single step, second as 2 steps, other is 2 and 1. So the total combinations are 3. The constraint that is given to us is n will be greater than or equal to 1 and less than or equal to 45. Let's switch to whiteboard and talk about a couple of approaches to solving the problem, including a brute force or naive approach and an optimal one. Let's use n as 5 or total number of steps as 5 to understand the approach. We'll start with the naive approach. The simplest solution to this problem would be using a backtracking approach. Here, there are 2 possible things we could do. One is to take 1 step at a time and the other is 2 steps. So when we are doing a backtracking, first approach would be to take 1 step, do the calculation and then undo the changes and then try with the 2-step approach. Let me show you with a couple of runs how will this work. So we are at step number 0 and we have 2 options. One is to take 1 step, the other is to take 2 steps. If we start with taking 1 step, we will be at step 1. Now from this point, we again have 2 choices. Either take step 1 or take step 2. So if we take step 1, we'll be at step 2 and then we'll continue this iteration with step 1 all the way to the end until we are at step 5. On the right hand side, we'll do the same thing. So when I'm at step 1 and let's say if I take step 2, I will be at step 3. From 3 again I have a choice to take 1 or 2. If I take 1, I'll be at 4. If I take 2, I'll be at 5, which is at the end. So now I've figured out one combination that will take me to step 5, which is start with 1, then 2, and then again 2. This is one unique pair. We'll continue the same thing for the rest of the legs to figure out all possible cases. So this is how it would work. If we try to visualize this approach on this step diagram, it would look like this. So from step 0, I will take step 1, then I'll take one more step, continue that until 5. Other combination is to go to step 1 using 1 step, then take 2 steps, then 1 and 1. Another option is from 0, I'll jump to 2, then 4 and then 5 and so on and so forth. So that's how this binary tree can be translated into visual approach. This approach, although solves the problem, has the time complexity of 2 raised to power n, where n are the number of steps. As the time complexity is super huge, it is not an effective solution. You will run into time limit exceeded exceptions. Now let's think about how we can improvise this solution. Let's try to understand this problem by thinking backwards. Let's say we are at step 5. To get to step 5, which steps I need to be at? Because we can only do 1 or 2 steps at a time, I either need to be at 4 or at 3. To get to position 4, there are 2 options. I either need to be at step 2 or 3. Because if I am at position 2, I can jump 2 steps to get to 4, or if I am position 3, I can take 1 step to get to 4. Similarly, if I am at 3, I need to be either at 1 or 2. And for 2, I either need to be at step 0 or 1. Now that we understand there is a correlation between the current step and the previous steps and which step we need to refer to. Now let's see how we can use that to our advantage. If I want to calculate the total number of distinct ways to get to 5, I need to add total number of distinct ways to get to step 3 plus total number of steps to get to step 4. Because when I'm at this position, I just need to take 1 or 2 steps to get to step 5. So this is how I can calculate the total number of distinct ways to get to step 5. Similarly, to get to step 4, I need to add the total number of steps to get to step 3 plus total number of steps to get to step 2, and so forth. To get to step 1, we already know that there is only one possible case. To get to step 2, there are 2 ways to do it. 1, 1 and then 2 directly. To step 3, if we use this formula, we will get step 1 is 1 plus 2, 3. Total number of distinct ways. Now to get to step 4, step 3 plus step 2, step 3 is 3 plus step 2 is 2. So total number of possible ways is 5. And similarly, we'll calculate for step 5, which is 3 plus 5, 8. Try to document all of the possible ways. For 4, it would be 1, 1, 1, 1, 1, 1, 2, 1, 2, 1, 2, 1, 1, 2, and 2. So there are 5 ways to get to step 4. The time complexity to solving this problem is O of n, where n is the number of steps. As we are building on top of the previously calculated values, we are not doing any duplicate iterations unlike the previous approach. And the space complexity is O of n, as we need to maintain the total number of distinct ways for each step. Let me show you how we can implement this using C#. Here in the main method, I check if the total number of steps is less than or equal to 2. If it is, then we simply return n, because if n is equal to 0, the total number of steps will be 0. If it is 1, total number of distinct ways is 1. If it is 2, the total number of distinct ways is 2. Hence, I'm simply returning it to avoid any calculations. I then initialize a result array to store all distinct ways for each step, preset the values for step 1 and step 2. I then start the iteration from step 3, where I'm setting the result of I by adding its previous value and 2 values before. That is I minus 1 and I minus 2. Once this for loop is complete, we will simply return the value at step of n, which is the step we want to get to. This is a very easy problem once you understand what exactly we need to do to solve it. The solution is also very straightforward. This solution beats 100% of the submissions made on LeetCode so far and beats 52% of the submissions in terms of memory consumption. I hope you were able to understand this explanation and the solution. The link to the code is available in the description below. Feel free to check that out. If you have any questions or concerns, feel free to reach out to me. Happy to chat about it, and I will see you in the next one. Thank you.